Hello. So the problem of the day is count the number of complete components. So we are given an integer n which denotes the number of nodes in our graph and a 2D integer array edges which denotes the edge between two vertices. And we need to return the number of complete connected components of the graph. Now, what do we mean by connected components? Let's see here. So for an example, this is the whole graph given to us. So a connected component means from this node we can go to this node and this node because there are edges between them. So this whole thing will be a single component. From this edge, from this node, we can't go to this node, okay? Because there is no path. So these two are two different components we have, okay? So the total number of components we have is two here, okay? Now what do we mean by complete connected component? So the definition given here, a connected component is said to be complete if there exists an edge between every pair of its vertices. What does it mean? That from a single node, if I need to have an edge to all the other nodes in a connected component. Okay. So let's see here. So from this node, I have two paths or two edges. So from this node, I have edges to all the other nodes. Okay. So from this node, I have edges to this node and this node. For this node, we have edges to this node and this node. So this is a complete connected component. Okay. Now let's see this example. Is this a complete connected component? This as a whole is a connected component because if we start from a single node, we can go to other nodes. Okay? So this as a whole is a connected component. But is this complete? Let's see. So from this node, I can go to this node. I have a vertex to. I have an edge to this node and this node. Okay. But is there an edge between this and this? No. So this is not a complete connected component. So to make this complete, we need an edge between these and these. So now we can see this as a whole is a complete connected component. So every node, the point to be observed is every node should have vertex to every other node in the component. Now, what can we observe here? If I have a whole connected component of n nodes, if we have a connected component of n nodes, means we have a component which have n nodes. So each node will have how many number of edges? Each node will have how many number of edges? N minus 1 edges. Like for an example, let's see this. So this whole component has total 4 nodes. Okay. So we have 4 nodes here and each node have 3 edges. Like you can see this is 1 edge, this is 2 edge and this is third edge. Okay. So each node will have n minus 1 number of edges. Now this is the property of complete connected graph. So what we'll do, we'll first check each component, okay, one by one. How can we do that? By using any BFS or DFS traversal. So first we'll count the number of nodes in each component and then we will check if every node of that component, note, every node of that single component should have n minus 1 edges. Okay, and if yes, then we'll increase the count, means that is our complete connected component. Okay, so how can we count the number of nodes in a component? We can do BFS. We'll start from a single node and we'll traverse to all other nodes and count how many components are there. Simple. But then we'll need to check every component of that, every component of every node of that component. Okay. So let's take an example. This 1, 2, 3, and 4, 5. This is the graph given to us. Okay. This is the graph given to us. 1, 2, 3, and 4, 5. Now what we'll do? We'll start the BFS from 1 and we'll make a vector components. I'll be storing every node inside this vector component and then I'll be checking every component's size, like the size of the number of edges that each node have inside that component. Okay, so the pseudocode looks like this. First we'll try running. So for an example, I have this 1, 2, and 3. Okay, so our component array will look like, will be empty. I'll be starting from 1. I'm at node 1, so I'll add this in our component array 1. Okay, then from 1 I can go to 2 and 3. So if I'm doing a BFS, I'll add 2 inside the queue and then add 2 in the component also. So 2 will be added in my component, then 3 will be added in my component. Okay, after this, mm, just a second. Okay, let it be. Hmm. Now in this components 1, 2, and 3, I'll check each, I'll iterate through this component array. So I have total 3 nodes. So int size is equals to component dot size. Okay, so in the size is 3. Now I'll iterate through every element in this component and I'll check if it has n minus 1 edges or not. So if where is the all the edges of a single node are present in the adjacency list, so I'll check there only. So if adjacency of I dot size, I'm checking the size that it how many edges it contains is not equals to size minus 1. So what we'll do, we'll just make a flag variable and I'll mark it as false and break. Okay. And after my loop is completed, I'll check if flag, then count plus plus. So if flag is marked as false, it means that the whole component is not at all complete. Okay. Now let's see the pseudocode for the, let's see the solution. So first we'll make the adjacency list and then we'll make vector int visited and vector int component. Now for int I is equals to 0, I less than n, I plus plus. What I can do, I can do any sort of traversal, BFS or DFS. Okay, and inside the BFS and DFS traversal, I'll make this component. So I should make it here only. So if not visited of I, I'll make a component. I'll initialize the component array. I'll do the BFS or DFS, and then I'll bring it down to here. So I'll do this check, and at last I'll be returning count. Okay. So just after you have done the BFS and DFS traversal, just check if all the nodes inside the components have n minus 1 edges, then we'll increase our count, means that is our complete connected count. Okay. So yeah, this is how the solution works. Let me show you the full solution. Here I'm making the adjacency list, and this is the visited array. So if not visited, I'll make a vector component. I'll just do the DFS and uh, make this boolean flag 1, and I'm checking this and increasing the count. Inside the DFS, inside this DFS, I'm making this component array. Okay. So whenever I'm visiting a node inside the DFS, I'm pushing it inside the component, okay, and marking the visited as well. So the whole DFS and BFS algorithm remains same. Just we need to add the node inside the component and check the size of the component. Okay. So thank you.